Hey guys, today we're going to add a hauling job to our worker NPC. Our worker is going to be able to pick up objects from the scene and take them to a stockpile. For this, we'll need an item and inventory system. This is the first step in making work-related NPC behaviors. And in this project, we'll have two kinds of NPCs. We'll have soldiers and workers. In the coming episodes, we'll work on the workers. We'll have haulers, miners, berry pickers, and perhaps also farmers. Then we'll work on the soldiers and on combat. Let's start by designing an inventory system. And why don't we start with items? So an item can exist in three states. It's either an item in the scene. In this case, we'll use an item which is a script or a mono behavior. Then it can exist as an item in the data. And in this case, we'll use an item profile, which is a scriptable object. And this scriptable object will contain like the name of the item, the price, the weight, the icon, and any information you want to add. Then this item can exist as an item in an inventory. In this case, you can call it item stack or inventory item. So these are the three main states that our items will exist in. Now let's talk about the item manager. This is a singleton that we'll add to our scene, and it will contain the list of all the items in the scene, and we can ask it to get the closest item to a position. This will be used by our workers to look for items and take them back to the stockpile. And for this, we'll use a simple list, but you can also use a grid for optimization. I already talked about using a grid system for optimization. In this episode, in the first Game AI Mastery series, the knowledge in this video will apply to this project as well, and any project where you have a large number of objects and you need to keep track of their positions. Then let's talk about the actual inventory. The inventory script will contain a list of item stacks, and we'll use this inventory in our stockpile at first, but we can also use it for characters. And now you have to really distinguish between the view layer of an inventory and the inventory itself. So the view layer, how we see the inventory and how a player may see the inventory, can be as basic or as fancy as you want. For example, in the game Elder Scrolls Oblivion, the inventory is simply a list of items. In games such as Animal Crossing, it's a grid, and you have a lot of tiny little interactions to manage this grid. And you can find view layers such as this one. This is a screenshot from Deus Ex Human Revolution, where you can have a grid, but items can be of different sizes. So the player has to do some space management. If you give each element a weight, then you can have your player managing the weight. And for example, if the weight exceeds a certain threshold, then the player will get slower as they move until they completely stop. So you can add all of these little elements to your gameplay. But in our case, we'll keep it simple, since our main purpose is not exactly to implement this inventory system, but rather to implement the NPC behavior of workers. And especially today, we're focusing on the hauling tasks. So let's go back to Unity, and in our scripts folder, I'm going to create a new folder called Inventory System. In this folder, I'll create all the scripts that we talked about earlier. I'll create an item script. Our item will be of type mono behavior, and we'll need a reference to an item profile. So let's create an item profile first. The item profile needs to be of type scriptable object. And let's add a create asset menu attribute, and let's set the menu name to tinyvillage/item. And here we can add all sorts of things. Like I said, we can add a description, a label, whatever your game needs, but we'll mainly need a prefab for now. So in the item profile, we'll have a reference to the prefab to create this item in the scene. And let's go back to item. So here we'll have a reference to the item profile. Let's create a public profile variable. Okay, now let's create an item manager. This will be a mono behavior, and let's have the list of items here. In the start method, let's populate this items list by the list of items in the scene. So we'll create a new list, and we'll use find objects by type of type item, and with the sorting mode set to none. And we're doing this because this find objects by type method returns an array. So we need to initialize the list with a list constructor. Let's go back to our item. So here we'll also need a reference to the owner of this item. So let's add a public GameObject owner. Let's add a method getClosestFreeItem. This works exactly like the method we created for the bed manager in the last episode. So we're going to look for the closest object. Let's have a variable closest of type item and a float shortest distance that will initialize to the greatest distance possible, which is mathf infinity. For each item, if we already have an owner, we'll skip this item. Then we'll get the distance between the position and the item's position. If this distance is lower than the shortest distance, then we'll update our shortest distance with this distance and the closest item with this item. And then at the end, we'll return the closest item. Let's go back to the Unity editor and let's create some items here. I'm going to create a folder for items with two subfolders, profiles and prefabs. Let's go into profiles. And I'm going to right click, create, then go to Tiny Village item. Let's call it Gold Nugget. And here I created a model. Well, I didn't really create it. It was available in the Tiny Toony RTS pack. It's a model of a rock. And I created this material, which is completely orange. So we're going to save this as a prefab. But first, let's add the item script here. And let's choose the profile, Gold Nugget. Let's save this prefab in the prefabs folder. Then what I'm going to do is go to profiles, then Gold Nugget, or I can right click properties to have this inspector here. And then let's go to prefabs and I'm going to assign our Gold Nugget to this prefab field. All right, both the profile and the prefab are connected. Now let's add the item manager. Here at the top of the hierarchy, we have the game managers. Let's create a new empty and call it item manager. And let's add our item manager script here. So in the script, I forgot to make this item manager a singleton. Let's do it here. Let's create a property, item manager instance, which will be static with a get and private set. And we're going to initialize it to this object in the awake method. Let's duplicate this object a bunch of times. And I'm going to run the game and just check if our item manager has the items. Okay, after running the game, you can see that our item manager has indeed retrieved the items. For the scripts, I just added the bare minimum. We'll probably need more methods and properties, but let's work on the hauling job first, and then we can add all these elements later. We already have a pawn script. Now to keep things clean, let's create a new script that will handle all the functionality of a worker, including the haul-in behavior and later behaviors that we're going to see. Let's create a worker script with an item property. Let's create a method find and reserve closest item. Then let's call getClosestFreeItem on the ItemManager.instance. Let's give it our transform position and let's store the value in found item. If found item is null, we're going to return. If not, we're going to set the owner of found item to this game object, which is the game object of the character. And we're going to set our own item field here to found item. We'll also probably need the items game object. So let's create getItemObject that will return the items game object. Here we'll probably need to check if item is null and return null. And then we're going to return item.gameObject. And we'll use this method inside of our behavior tree. Since our worker will have an idle and a sleep behavior, we'll need to interrupt those. So to interrupt them, we'll need a condition or a conditional in the case of Behavior Designer. Let's go to Tasks, Conditional. Let's create a new condition called isItemAvailable. Here we need to import all the observe namespaces. So observe.behaviordesigner, runtime tasks. Probably we don't need runtime tasks actions. Then runtime tasks conditionals and observe graph designer runtime variables. You can find those in the documentation, just copy and paste here. Our class will inherit from conditional. Let's override the onUpdate method. Here we'll probably need an isItemAvailable on our item manager. If this method returns true, we'll return success, otherwise we'll return failure. So let's go to our item manager and let's create a new method. Public bool isItemAvailable. we loop through the list of items. If an item doesn't have an owner, we'll return true. Otherwise, when we get out of the loop, we'll return false. So this is a simple method that our NPC is going to call. We can probably make a more optimized version of this method since the item manager has full control over the list of items. I'm not going to do it right now, but this is just an idea. Okay, let's go back to the conditional. All right, so this is it. Now let's go back to Unity. Let's go to the worker and let's go into prefab mode. Now let's open the behavior tree of the worker. So here we have the sleeping branch. Let's collapse it. And here we have the idle branch. And now over here, we're going to add a new branch. So let's create a sequence and let's connect it to the selector. And for this sequence, we'll need an abort type set to lower priority. And let's add a conditional here. Conditionals is item available. So if this one is true, then we're going to interrupt all of these children, or I should say the siblings of this sequence. So we'll interrupt sleeping and we'll also interrupt the idle behavior. So indeed, this is the highest priority task right now, is to haul items. It probably should not be higher than sleeping. Okay, so in fact, let's have sleeping over here. Sleeping has the highest priority. Or let's keep it this way right now. So once we have items available, we'll need to get or find and reserve item. So let's add a new action. We can go to code base, then tiny village, then worker, find and reserve closest item. Then let's add get item object to the same stacked action. We can save it in a dynamic variable. Let's call it item and let's connect this stacked action to the sequence. Now let's add another action. Go to object and we're going to give it our item. So let's click on this dot and let's set the destination to dynamic. And here let's enter the name of our object, which is item. So we'll go to item and we'll keep the arrive distance at, let's keep it to 0.75 and let's connect this action here. Okay, so now we got our item and we're going to it. And once we reach the item, we need to pick it up. But let's just see if this works. We still need to have the worker component on our pawn. So let's add component worker and let's put it up here. Okay, let's run the game. So our worker has found an item. It's gold nugget 3. If we go into the behavior tree, we can see that the worker has interrupted all the lower priority tasks and is now going to the item. So he's going to the item. He has reached it. Now let's go back to worker and let's add a transform reference here. So now we need to pick up the item, and in order to do that, we'll need a reference to a transform to match the position and orientation of the item to that transform. We could also make the item a child of the character. That's also a possibility. Let's call it carry root. We'll also need a variable to indicate the state of the item. So let's create a bool item carried set to false by default. And down here, let's add a method. Let's call the method carry item. If we do have an item, we'll set item carried to true. And now we'll need to add an update method here. If item is carried and item is defined, we'll set both the position and the rotation of the item to the position and rotation of carry root. Here, just for good measure, we want our worker to be on the same game object as the pawn script. So let's add a require component attribute with type of pawn. That way we can get a reference to the pawn here. To be honest, I just want a reference to the animator. I don't even need the reference to the pawn. So let's not have it here. I'm just going to have a reference to the animator. In the awake method, let's get the animator. Okay, so when we're carrying the item, let's not check for item here. Let's just keep it simple. If item is carried, we're going to do this. So our worker will have a tool. And when we're carrying an item, we should hide that tool actually. So let's create a field, game object work tool. In the update method, if item is carried, if item is not null, then we're going to do this. And we'll also set the work tool to inactive. Let's add an else statement here. So if we're not carrying an item, we'll set the work tool to active. Let's go back to the editor. I'm going to right click properties to have this worker inspector here. I went all the way down to the right hand. So here we have the right hand container. Perhaps we can use this as carry root. As for the work tool, let's set it to pick. So this inspector is still a bit of a mess, but we're not going to care about it right now. Let's just focus on getting the functionality right. Okay, let's keep this inspector open and let's run the game. So our worker is going to this object. Then he seems to be going back and forth. Okay, let's go back to the worker's behavior tree. So here, after going to the object, in this stacked action, let's add a shared wait. Let's just wait for 1 second before carrying the item. So let's add an action, code base, tiny village, worker, carry item. Then we need to go to the stockpile. Let's add a new variable here, just a temporary variable. Let's call it stockpile, and it will be of type game object. And here now go to action. I'm going to use the variable. Let's set the arrive distance to 3, for example. And after we went to the stockpile, we'll wait. So let's add a shared wait. And after this, we need to drop the object. So let's go back to the script. Let's create a drop item in stockpile method. And here let's call ItemManager.instance destroy item. We need to define it because it's the item manager that's responsible for handling items. So let's go to the item manager. To destroy an item, we'll remove it from the list and then we'll destroy its game object using destroy. Let's have the stockpile be somewhere near this market. Let's create an empty inside of this building and let's have it over here. So this area will be our stockpile. Let's rename the object to stockpile and let's assign it to the behavior tree variable. So let's drag this value and drop it on our behavior tree variable here. So our character is going to pick up these items and take them over here. Okay, let's open up the behavior tree of the character. So he's going to go to the stockpile, then wait. Then we're going to call drop and destroy item. So let's hit space and let's type drop. And here we have drop item in stockpile. So we're going to call it. And that way the item will be destroyed and our character will start over again. Okay, let's see what happens. So our character went to this item and he picked it up. So he picked up the first item and he took it to the stockpile. But for the other items, they teleported to him and then he dropped them to the stockpile. So when we drop the item to the stockpile, we actually need to set this item carried to false because this is in a way a finite state machine that we've created here. So we need to reset it to false. Okay, so when we do this, we need to reset item carried to false because otherwise the character will have the impression that he's carrying the item and will drop it. Okay, let's see this behavior again. So let's have our hauling branch visible here and let's have our scene view over here so we can see what happens and at the same time look at the behavior tree. Okay, so let's run the game. Our character is going to the first item, he's picking it up and dropping it, then going to the second item, picking it up and dropping it, then to the third item. And when carrying the item, you can see that the tool is hidden. We don't see the pickaxe anymore, and that's great. Perhaps when the character is carrying the item, he can walk to signify the weight of the item that's being carried. And perhaps we can play another animation. So here you can see that the character has went to sleep. Okay, so let's modify our behavior tree. Here when we're going to an object, let's call run or set run. Let's have it at the top. So let's have set run set to true. And when we've carried the item, let's add another wait here, shared wait. And then let's call set run and have it set to false by default. And why don't we combine these stacked actions? Let's call drop item in stockpile. And then let's duplicate shared wait. These wait actions will add some life to our character. Okay, so we have this. In fact, let's use a sequence here. Using a sequence here will make our graph a bit easier to read. So here we have this condition and then we have this sequence. So this is a bit better looking, what we can do is perhaps duplicate this character, have 2 workers and a lot more objects. So let's duplicate this gold nugget a bunch of times. And let's have our stockpile a little far from here. So let's click on the stockpile. Let's have it near the door perhaps, just so we can see the characters walk a bit longer. Okay, let's click on this character and let's focus on the hauling branch. I'm going to lock this view and then run the game. Okay, so each character is picking up an item, and while they're carrying the item, they're moving slowly. And now they're going to drop their item. And you can notice here the little pauses really add some life to the characters. So actually, to make the animation a little bit better, we have a two-handed weapon animation. I'm just repurposing the animations. We don't really have a carrying item animation. So if you go to the Toony Tiny People package, here in the animations, let's go to infantry. Let's go to two-handed. So here I'm going to drag and drop my character. You can see here that the characters walk like this. So this will look better for carrying items. And then for idle, they're holding the item like this. And that will work fine for our purposes. So let's go to the animator. Let's duplicate the locomotion blend tree. Let's call it carrying. And let's add another boolean here. Let's just call it carry. And we'll move from locomotion to this carrying state when carry is true. So we're going to uncheck has exit time and add a condition. The condition will be carry is true, and then we'll go back. So let's make a transition from carrying to locomotion. Let's uncheck has exit time, add a condition, carrying is false. And then let's go into the carrying blend tree. So here instead of shield, I'm going to use these two-handed weapon animations. So two-handed idle instead of shield idle. Two-handed walk instead of shield walk, and two-handed run instead of shield run. Now back to our script. Let's go to worker, and in the update method, if item carried is true, we'll set the carry variable of animator to true. Otherwise, we'll set it to false. Okay, let's run the game. Okay, so they're carrying items. In fact, why don't we add more than one worker? So let's apply the overrides on this worker. So let's create 4 of them. And why don't we have the stockpile a little closer? Perhaps, yeah. Let's keep it over here. It's fine. Because now they're walking, so they'll take way longer to reach the stockpile. Okay, let's run the game. Our workers are carrying the items. And this one is going to sleep, but only because they don't have any items anymore. Let's actually have the reference to the stockpile in the item manager. So let's edit the script. So here we can have a lot of stockpiles and have the item manager return the closest stockpile, etc. But let's just keep it simple. Let's just have one stockpile. So let's create a game object stockpile. And in the worker script, let's create a method. So let's go to the worker script. Let's create a method to get the stockpile. That way we can use it inside of Behavior Designer. So let's add a public game object, get stockpile. So in fact, we're going to need a get closest stockpile on the item manager, and we'll give it our transform position, but it will always return the one stockpile. Right now, having one stockpile is fine. Okay, let's go to the item manager. So let's define get closest stockpile, and it will ignore this argument and just return our one stockpile. And this is fine for now. So let's go to our workers behavior tree. Okay, so in this last tagged action, we're going to the stockpile, but before we do it, let's go to codebase, tiny village, then worker, then get stockpile, and let's put it at the top. Let's actually delete this variable. We don't need it anymore. Remove. Let's go back to our action. So when we get the stockpile, we'll store it in a dynamic variable. Let's call it stockpile. And in the go to action, For the destination, let's set it to dynamic and let's enter the name of our variable, which is stockpile. So we're getting the stockpile and we're going to it. Then we're waiting, then dropping the item, then waiting a little bit. This is great. Now we should be able to have a working behavior without needing to assign the stockpile variable. Okay, now we need to go to our item manager, then assign the stockpile variable. So let's assign it here. Let's drag and drop the value to this field and let's run the game and test if everything is working right. Okay. So our characters are carrying the objects to the stockpile. Okay, that's it for this video. So we've added items. We did not add an inventory system, but the focus of this episode was really to get the hauling behavior working. And so far we've achieved this goal. So thank you for watching and see you later.